All right, class, we're going to go ahead and look at 7.5, which is the last section of chapter 7 that we're going to deal with in this class. We started off by looking at the principal values and talking about cosine, sine, and tangent. And we said that sine and cosine have the same principal values. So we're looking at values between that are just one number. And for sine and tangent, we said that they were looking for numbers that are between negative 90 and positive 90 degrees, or negative pi over 2 and positive pi over 2. And then for cosine, we said it's going to be between 0 and 180 or 0 and pi. So when we're looking at principal values, when they specifically say principal values, they're looking for one value answer, or one answer itself for that whole graph that they're looking for. One answer particularly. So let's take a look at example 1. And example 1, and we're going to start with A. So this one says solve sine x cosine x minus cosine x equals 0 for principal values of x. So once again, principal values. So we're looking for one answer for this when it comes to our sine and cosine functions or any of the functions that we're dealing with. And so express the solutions in degrees. So make sure you remember how to do degrees and radians, because we're going to deal with both of them in this section. All right, so let's take a look at this one. We're going to pull this down. Set that equal to 0. And so we're going to take a look at this. We need to solve this down to get like one trig function, really. One or two trig functions at the least. So what we're going to do, we're going to look at this as a regular expression or trig value or anything of that sort, something like that. So what we're going to do, an algebraic expression or algebraic equation. So what I'm going to do, we're going to make this y times x minus 1/2 x equals 0. So we can say y is like cosine x. We can say y is like sine x and x is like cosine x. And so we substitute those in there and look at how do we solve this function here, this algebraic expression, and get it by itself. So the first thing is, okay, we look at it. We have two things in common. We have x's in common here. Those are two things that they have in common. So we're going to pull out what they have in common there, which is our x. So we pull that out. We have y minus 1/2. And then solving this out, we use the zero product principle. And we do x equals 0. We do y minus 1/2 equals 0. And so we have y is equal to positive 1/2. And then x equals 0. So if this is what we did for an algebraic expression or algebraic equation, we do the same type of thing over here for the trigonometric equation. So we're going to solve this out here, just like we did here. So we look at, okay, what do they have in common? And we pull that out first. So in this case, they have a cosine in common. So we pull that cosine out. So I give you sine x minus 1/2 equals 0. Alright, so just like we did over here, the zero product property, we do cosine x equals 0. We do sine x minus 1/2 equals 0. And then we solve them out. So cosine x equals 0, we leave it there. And then here we have sine minus 1/2, or sine x equals 1/2. So in other words, we add 1/2 to both sides, and so we get sine x equals 1/2. So we're looking at these two values here. We should get one answer for cosine x and one answer for sine x. So for cosine x, we're going to look at what values between negative 90 and positive 90 degrees, because we're dealing with degrees here. Looking at where between negative 90 and positive 90 that cosine is going to equal 0. And so with that one, we have to think. Where is it? Remember from our chart, or if you remember from the graph, what a graph looks like between negative 90 and positive 90, you would see that x is going to equal 90 degrees. So that would be the only answer that cosine would equal x, or cosine would equal 0 for principal values. So that between that range of negative 90 and positive 90, like we just said on the screen before. All right, so here then we look at, okay, sine. So sine x equals 1/2. Where between negative 90 and positive 90 does sine equal 1/2? And you have to think back to your chart again, or think back to the graph, and you would see that would be 30 degrees. So x would equal 30 degrees here. So it's pulling back that chart we talked about before, and all the information we talked about before with the graphs and the radians and degree measurements, and we're putting it all together in this. So like I was saying before, we put everything together in chapter 7. All right. Now, what we're going to do next, we're actually going to give you a practice problem to work on. And I'll put the answer up at the very bottom so you can actually see what it looks like, or what the answer really is, so you know you're doing it right. All right, so we have, let's go back up top first. So we have 2 sine squared x plus cosine, 2 sine squared x plus sine x minus 1 equals 0. So we're going to solve this out doing the zero principal property. Not zero principal property, sorry. We're going to solve this out using the trig identities and everything to be able to figure out what the principal values are. And when you get to the end, your answers will be negative 90 degrees and positive 30 degrees. So those are your answers that you need to work with, and then work backwards or work through it to get those answers here. And if you have any questions, I'll put the notes up on Edmodo for you guys. All right? See ya.